Okay, this is to help how to find law and integrated law when you have concentration in time. When you have only concentration in time, you're gonna use make a line time in the concentration graph. To do this, you need to use a calculator. Enter. You go to stat, and then you press edit. Edit right here. For L1, you can put either the concentration or the time. Let's say if I put the time, I'll put 0. Then it's like 50, 100. And 200. All right, then L2 will be the concentration, so it'll be 0 0.1, 0 0.7, 0.0707, 707, 0 0.05, 0 0.025. All right, and then from here though, you want to also you want to find order of the rate. You have to use and remember that for a first order, it is natural log of concentration versus time. For a second order, it is 1 over concentration versus time. And then for zero order, it is simply concentration versus time. All right, so you have here, then you want to find like the natural log value, also while also finding the 1 over the concentration value. So what you do is go to L3, press enter on L3, and then you just type in natural log, which is Ln, and then you go to second stat, which is bit list, go to L2 here, and then just press enter, and here you get all the natural log values. Enter here if you want to find a 1 over concentration, 1 over second stat, list 2, that's the original one, and then boom, calculate. Alright, go to now second start plot up here. Go to plot one on. First one here, this is scatter plot. You want to do scatter plot. X-axis will be L1, which will be the time. The y-axis, we can start with the concentrated cell to see if it's zero order or not. Press enter, then graph. Right here, right now, you can't really see anything because you know it's not zoom in. But you can just go to zoom. Press 9, because zoom 9, if you go all the way down, it is zoom stat. Zoom stat, and boom, you have it right there. Does it look straight to you? No, not really. So try something else. Second quit, second start plot, enter, change this, change it to X list, Y list, change it to, let's say, L3. Now remember, L3 is the natural log of it. Let's try again. Graph, again, zoom, 9, boom. Take a look at that. That's pretty damn straight. Alright, so we can almost assume that it's like, I don't know, first order. But let's just try again to see how it goes for the natural for the second order. So you go to second start plot again. On, go to L4, single stat L4. Graph again. I think you're familiar with this now. To 9. Oh, that looks like exponential function to me, not exactly linear. You want to make sure that the points make it look like it's linear. All right. So obviously that this thing is obviously a bloody first order. Okay, so now if you want to write rate law, it will just be R equals to K times R equals to K times A. Because this is so rate law. Right here. Equals to R equals to K times concentration of A, because it is a first order. Alright, now once you want integrated rate law, you will have to use something else. Go to stat and then go up there, calc, then go down, go to linear regression, alright, and then type in the value 1. Since we use natural log, it's L3, go second stat L3, boom. And then you can store the regression through vars, y bars, function, y1, like that, and just calculate. And take a look at that. You get everything right here. So, you know, the integrated law for first order is just simply now the integrated law will just be equal to the natural log of A equals to negative kt, to k will be the reaction constant, plus L1 A naught, which is a initial concentration initial. And you have to make sure that k will always be positive. The slope will always be the positive value. And yeah, that's what you're trying to make I'm trying to be careful about. So then you can write the integrated law. I wrote it down here. Natural log equals to negative 0.0693 from what I got here. See the ax plus b. That would like so the a here would just be like the k value, which is the slope. And then the even though it's supposed, and then remember I said it's to negative kt plus l in a naught. Well, here the b, which will be the l in a naught, it's negative. So this is a plus. This is no, it's a negative. So it's just going to be minusing that value. So yeah, so this is all. This is for how to solve when you have only the concentration and time. Yeah, so I hope this helps.